So 1 or 2 members are came. Durga Kalyan came. Not 1 or 2, only one person. Check it. Akula Kola Devender, Mahesh Rao, Bhargav, Santosh, Kiran Gaud. Hmm. Okay. So what is this IP address and what is the subnet mask? When you want to assign an IP address, you have to tell IP address and the subnet mask. Guys, the IP address is actually two parts. One is network portion, another one is host portion. Another one is host portion. Okay. So one is network portion, another is host portion. The host portion actually the identification of host. Identification of host means your device, computer, laptop, PC, mobile phone, printer, whatever you can say, like a host. It's like yours. Network represents a logical network. Okay. So in the IP address is two parts. Network part is there, host part is also there. Example, PIN numbers like our PIN numbers. If you are in Hyderabad, it's a 5000118. What is this 5 represents? The area, geographical area, maximum Telangana, Hyderabad, some part of Karnataka. Okay. So like a city representation. This is area representation, like a town. Like if you see 530,018, but this is different town. Almost it's like geographically same, but different town it is. In that one, which part of town? Like which area it is? Okay. So we'll go back once again. Um, we have a four numbers like a 0515A, 05A15B, 0402. This is my roll number. So like which year, college code, branch, and this is roll number. Almost all my classmates having this roll number only 403, 401, 4, 5, 6, like this. What is that not changing? Only this part, roll number is only changing. Remaining is constant only. This is entirely constant for everyone. Okay. For example, I have like this. The number is like this. 202. Now it is changed. This portion is changed. This is our main host. This is you, but this is changed. What is this represent? It is like a branch. I am from ECE, mine is 04. Someone from CSE, 02, branch. But both are having a common. So commonly same college, but different branches. Commonly same college but different branches. Commonly same branch, same class, but different roll numbers. It's a your own identification. This is branch identification. This is college identification. And this is year identification. Like how we are dividing all these things. So like that only we divide our IP address into network and host portions. Like if you take a floor numbers, roll numbers, floor numbers. For example, you are a ninth branch, right? So I will take I will assign a numbers to you. Hyderabad, ninth, 01. H, 902. H, 903. It means what? All are belongs to same batch, but you are having different roll numbers, right? So this is for identification. There is another previous batch is there. H804 is there. But both are different person, both are different branches, both are different branches, both are different number persons. Okay. You guys understand some part like the difference. What is the common? What is the not common? Network address is always common. Host address is different. Okay. This is the important point. Network address always common. Host address is different. I told about a direct subnet mask, but today we'll discuss the subnet mask, network portion and host portion. IP address is divided into network portion and host portion. Okay. The first portion of class A IP address, if you take a class A IP address, then the first portion is network portion. Remaining is host portion. By default, guys, by default. So it can be changed based on the subnet mask. Class B, the first two portions are network portion, remaining is host portions. Class C, the first three portions are network portion, remaining is host portions. Okay. So what I'm trying to say is, if device are want to communicate in the network, their network portion must be same and host portion can be different. You have a two devices in the same network, same logical network means their network portion must be same and host portion is different. Okay, host portion is different. Network portion is always same. Okay, devices are in the same network can communicate each other means their network portion is must be same. Devices are in the same network means their network ID is also same. But all these rules only applicable if they are in the same logical network. Same logical network. So they want to communicate each other means like you think it is the same logical network, same network there are there. It means their network addresses must be same. Their network ID must be same. Okay. How can you calculate? Just by taking the default assumption. You can take it and tell them so they are in the same network. But how system can able to find it? How system can able to understand? So what is the network portion and host portion? So that is they use subnet mask. Here I written one more point is the entire host portion should not be the same in the same network. At least one of the host portion must be different. Guys, if you see, this is entirely host portion, host portion, host portion. It is not required to be completely different. Not should not be entirely same. Means 110.12.22.33. 110.12.22.33. No, no, no. You should not put the same IP address for both the species. The host portion must be different, not required to be all the host portions. So any one of the host portion is different, that is allowed. So I will show you somewhere it is. It's a this is a network portion. So this is must be same. This can be changed like a 24.25, 24.26, 24 by 37. Now it is both portions are different. It is allowed. Okay. Can be one different or can be both all the portions are different. No problem. Okay. So the entire host portion should not be same, but at least one difference is required or multiple differences also can be possible. And next one is how the system divide the network portion and host portion. They use subnet mask. Already I told yesterday. Okay. Today is 8th. What happened? Okay. So how system knows what is a network portion, what is a host? Guys, if you have a two system and you are connected, then you configured an IP address to it. Okay. Both side you give an IP address. And you started communicating from this PC to this PC. But how this system understand this system is in the same logical network or not? Both are in the same logical network or not? If it is not there, then what will happen? That is second part. But you both are in the same network or not? How it will understand? So what it will do? It will check the network portion of the IP address, its own IP address. First, network portion of this, and network portion of the destination. And this network portion with this IP address, it find a network ID. From the IP address itself, it find a network portion, then it will understand what is the network ID. Okay, and this network ID. In this system as well as this system verifies both are having same network ID, so they can communicate each other. If their network ID is not same, they won't communicate each other. Okay, so system use a subnet mask to divide IP address to network portion and host portion. What is the system is using? System using what user is configured or it is what are the IP address and their subnet mask under it. it will use that subnet mask and calculate a network ID and divide the IP address into network and host portions and calculate the network ID. If both the system network ID matches, they will communicate each other. Otherwise, they cannot communicate each other in the simple LAN network. And how it is do calculation? It use a logical gate called a AND gate. Logical gate called a AND gate. What is this AND gate operation? So if both inputs are high, output is high. If both inputs are low, output is low. One input is high, other output is low, output is low. Okay. So it is like that. If both inputs or any input is lower, output is lower only. Okay. If both inputs are high, output is high. You take a number like 1, 1, 0, 1, 1, 0. Sorry, it's okay. It is also good. 1, 1, 0, 1. It's a 8-bit number. And this side is 1, 1, 1, 0, 1, 1, 0, 1, 0, 0. Simple like this. See, this is 1 and 0. So 0. 0 and 0. 0 only. 1 and 0. 0 only. 1, 1. It is 1. See, it is this one and this one. So logically 1. 1, 0. It's a 0. 1, 0. It's a 0. 1, 0. 0. 1, 1. 1. Okay. So this is our output. Okay. So this is a AND operation, guys. You have to compare the significant bits like this one, this one, this is, and do the AND operation in between. Means you both are ones, output is 1. If any one is 0, output is 0 only. Guys, understand AND operation?
Yes, sir.
Okay. Good. If you take a subnet mask, you write this subnet mask into the binary. The ones represent network bit, zeros represent host bit. Okay. If you take an IP address like a one network 192.168.1.0, it's a class C network. The very starting IP address that is start with a 0, so that is called a network ID. We cannot assign these network IDs to any device. Of course, we can use any unicast IP address, but again, in one single network, we cannot assign to the any device. And the last in the network, this is the last IP address in the same network, is a broadcast ID. That is also we cannot assign to any device. In between, any IP address is there, we can able to assign. Okay. Very starting one and the last one, we cannot use it. And if you are observed, guys, it is 190.168.1.0, 1.1, 1.2, 1.3, 1.4, 1.255, that is the last one. 1.255, 1.254, 1.255. So you can, after 1.255, it is 2.0. 2.0 means the network portion. The first three portions are network portion, right? Third one, network portion is changed. So it is up to here, from starting from here to here, it's a one single network. And this is a different network now. So devices in this network can communicate each other. You can assign an IP address from this range 1 to 254. You can assign to the device's IP address. You cannot assign 0, can't assign the 255, the last one and first one. You can't assign to anyone. Okay, the very first one with a 0 that represent network ID. The very last one represents broadcast ID. Okay, this is one network. So here is the point is how you can able to find the network ID. How to find a network ID. So sorry. The last class I've written here a few points. Look at here, there is an IP address. Okay. And there is a subnet mask. So how to find a network ID? Do the AND operation between them. It's a 183. So this is, if you are convert this entire number into entire 183, this is 183, this is 15, this is 33, and this is 44. And again, this is 255. Okay, if you are convert 255.255.0.0, so this is the our binary number. And do the AND operation. So simple. So the first one is 1 1 1 0 1 0 1 1 1 1 1 1 0 1 1 1 1 1 1 1. Always look at this 0, this 1 1 1 1 1 1 1. Again 0 1 0 1 0 0 1 0 0 1 0 0 1 0 1 1 1 1 1 1 1 1 0 0 1 0 0 0 0 0 0 0 0 0 1 0 0 0 0 0 1 0 0 0 1 0 1 0 0 0 0. So this is the network ID. So what it equals to 183.15.0.0. Okay, this is how system will find network ID. You take another IP address. Okay, if another system having something instead of 44, it is having a 55. This is not changing, same network. Okay, and subnet mask is also same. I configured IP address as well as subnet mask. This is up to here same. Only the last part is 55. The 55 in the binary, so it's a 0, 64, 32. 32, 35 minus 2, 23. 23 means 16. 4, 7, 0, 1. If you have a doubt, you can use the calculator also in the standard scientific, not scientific, programming. So 55. So check it. 0, 0, 1, 1, 0, 1, 1, 1. Yeah. Okay. This is 55. Remaining are all same only, right? So I don't need to calculate. Again, do the AND operation. So anyway, first one is 1, 1, 0, 1, 1, 1, 1, 1, 0, 1, 1, 1, 1, 1, 1, 1. 0, 1, 0, 1, 0, 1, 0, 1. 1, 1, 1, 1, 1, 1, 1, 1. 0, 1, 0, 0, 0, 0, 0, 1, 0, 1, 0. 0, 0, 0, 0, 0, 0, 0. 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 0, 1, 0, 1, 0. Again, what is my resultant 183.15.0.0. See, the both systems are same network ID. So both systems same network ID means they will directly communicate each other. Okay, they don't require any gateways or routers are required to communicate. Okay. Guys, understand? If you don't understand calculation, it's okay. But do you understand the concept? Two PCs are there with this one PC, this IP address, other PC, this IP address. But their network ID is same, so they can communicate each other. Nothing.
Yes, sir, we got it.
Very good. So here it is. What is these numbers? And why we should require different network portions and different host portions for each and every class? Why we have to divide the IP address into different classes? Okay. So there is a reason. Look at here. So I want to define a network. Okay. I want to tell this is my network. And this network, I have a number of devices are there. Depends upon the number of devices, I can take a network. Okay. So for example, if I take a network, from one network, there is a network portion and one host portion is there. So these number of host addresses under same network, what time I'm getting. So based on that, I will choose this network ID for this network. Okay. An example here it is. If you take a class C IP address, already I showed that class C IP address. We'll see this once again. So this is a class C full C network. It is 192.168.1.0 network it is. So from here, if you count from 1 to 254, if you count 1 to 254 means, so one class C, you are getting 254 device IP addresses. Of course, totally it's a 256, one for a network ID, another is broadcast ID. Both are we cannot assign. Network ID represent what network it is. Broadcast ID is for broadcasting packets within the logical network. Okay, this is number of 250 up to 254 devices. I can connect with a single class C IP address. Single class C IP address. Okay. For example, my network is more than 254. For example, 300 devices are there, 500 devices are there. Then what to do? So we'll go to this class B, calculate class B. Class B having a two host portions. One portion means 8 bits. This is the 8 bit and this is 8 bit. Because octet, right? So it's a 4 octets. Each octet is 8 bits. Even if you are see the conversion, so it is 8 zeros. 0 represent host. 1 represent network. Okay. This is how many host bits are there? 16 host bits. But 255.0.0. See, it is 16 host bits are there. 2 to the power of 16 is 65,536. And there is a minus 2. So it is 65,534. Okay. So it is, if you take class C in one single class C network, it means, if you see this one, in this network, I have written only 2 IP address, but you will get almost 65,534 devices can connect in single class B network, without changing its network address. Only the host, number of hosts we can connect is 65,534. This is number of devices we can connect. This, for example, I have a large organization. In there, I have 5,000 computers. Which one is better? I will configure class C. Sorry, class B. Class C is 250 for support. One single IP, 250 for single networks, 254. Class B, single network, 65,534. Class A. Class A is, if you see, there is a 3 host partitions. 3 host partitions means 3 into 8, 24. 2 to the power of 28 minus 2 is 16. 16 million triple seven 1,214. Okay. So that's a million count. Now it is 1 crore 67,000 lakhs 77,214. Easy to remember, 16,777,214. These many, like I have more than 65,000, 70,000 devices are there in my single network. I want to connect all these network in a single logical network. I want to make them to connect as a single logical network. Which is the better one? Class A. Which is the better one? Class A. Okay. So that's why we divide an IP address into different classes. Why we are dividing? So based on the your network size, you can choose which class of IP address. So based on that number of devices, you can able to connect it. Okay. So that is the one of the main importance of dividing IP address into different classes. Guys, understand what I told? Here also I given some example here. So this is 44. Here I have taken 6, 22, 6. So it's a 33, 44 IP address. But subnet network ID is this one. But if you look at here, it's a 22, 6. But still same network ID means both the systems can communicate each other. So when you change the subnet mask, ఏం పని చేయట్లేదండి ఇది పని చేయట్లేదు ఇదే పని చేయట్లేదు మెయిన్ గా అది తెలియదు దాని గురించి
ఏది నొక్కేస్తుంటారు ఎవరో అయితే టెంపరేచర్ కూడా రావట్లేదు వస్తున్నా లేదు.
Okay, if you see, this is my subnet mask. Earlier subnet mask is different. See, this is the subnet mask earlier. Now the subnet mask is different. I change my subnet mask, not the default one. And I use same IP address 3354.22.6 here. So what you are getting? Both network IDs are different now. Both network ID are different now. Okay. Understand, guys?
Yes, sir.
Yes,
Okay.
sir.
This time, both network IDs are different, so they cannot communicate each other just by changing subnet mask. Okay. So, what is this concept is called a subnetting concept. What is the subnetting concept is divide one network into multiple subnets. So as I said, if you take a network is 254 class C, in a class C itself you will get a 254 devices. I can divide one network into multiple subnets. Entire one network into multiple subnets, I can divide it. Simply by changing the subnet mask, the IP address is divided into multiple. One single network divided into multiple subnets. Each multiple subnet have a limited number of hosts. Again, the number of hosts will be changes per subnet. Okay. Number of hosts per subnet will be reduces. How to do subnetting? By changing the subnet mask. How can you do the subnetting? By changing the subnet mask. So if you see initially, this is with the default subnet mask, the IP address, and this is a network ID. And this is another IP address, default subnet mask, and the same network ID. In this condition, both are in the same network. I just change the subnet mask. Now both are in the different networks. Just like that, it is happening. Of course, the deep explanation of subnetting is there, how to calculate the subnetting principles and all. Okay, but I'm not doing that one. So if you have any time separately later, we can discuss it. Okay, but what is a subnetting? Divide a network into multiple subnets. Why we need to divide a network into multiple subnets, guys? In our private, we can use the private IP as whatever the private IP as your choose, you can do it. I will explain what is the private IP and what is their different sizes. I will explain it definitely. But public IP addresses are limited. Total IPv4 itself is 4.3 billion. Okay, 4.3 billion. In the entire world, it is not enough. For each network, for each home, we have a network right now. Each device, we need an IP address to communicate. But in a 4.3 is not enough. In that two classes are reserved purpose only, only certain specific purposes only. Okay. So with the remaining things, it's not enough, right? So what we do for public communication, we are telling this is the public IP. For private communication. Still, for example, an organization required, in an organization, there is a 10 servers are there. So they need a public IP address. So then these servers can be accessed through public internet. For example, you take Zomato, Swiggy, Google.com, Gmail.com, Facebook.com. If you can able to access means their servers are having public IP address. Okay, having public IP address. So you can able to access. For example, in my organization, I have a 10 servers. So publicly people has to be access. So I need a 10 IP address, but the class C itself, we are getting 254. In a class C, we are getting 254 maximum IP address, but I need only 10. So you take a network, public IP network, you take it. So your requirement is 10. So what about the remaining unused IP address? You have to pay for the public IP address, but you are not at all using it. So what about the remaining IP address. So in that cases, the subnetting is a more important role here it is. So we divide this 250 for network. We take one network, we divide into small pieces based on the client requirement. We'll give that network to him. Okay. A client is required 10 servers, 10 IP address. We cannot exactly give 10 IP, but we can give 14. Means 16 minus 2, we can give 14. Another client is required, another company requirement is 50 IP address. So we'll divide that the network into small pieces. We'll give 50 to him. Okay, we'll give 50, exactly 50. It's difficult, so we'll give 62. So wastage of IP addresses will be lesser now. Best utilization of public IP addresses are increases. Of course, other features also. Okay. What is the use of subnetting, guys? What is the subnetting? Divide one network into multiple subnets. What is the why we should divide one single network into subnets? Depends upon the network size. Okay, we have to divide our one single IP into multiple subnets. In different scenarios, in public IP address, the organization require 10 IP address, but not want to pay for the additional IP address which is not used by that organization. We divide the public IP into small pieces by using subnetting, and we can give that IP address to the client. That is subnetting. Okay. Even for a private network also, we can do the subnetting. Why? Because I have a very big network. Different departments are there. All the departments IP address must be look like same, but they should logically we should divide it. So I will change the subnet mask. I will tell all these 100 computers one department. They will get an IP address, but different subnet mask for that. Another like this, I can divide. I'll take one class B IP address, 65,530 for a host, I will get it. In that one, again, I will subdivide them. Each network, they will get only 500 systems. Okay, like that, I can configure. Okay, that is a plan of subnetting. But if you really want to learn the subnetting, there are a lot of available resources are there. But right now, if you have a time, so separately, one specific day, like 2-3 days, is required to calculate subnet. Right now, I'm not doing that one. After the completion of all the syllabus, if you like it, you can remind me. I will tell you. Yes, up to here, understand what is the use of subnetting.
Yes, sir.
Very good. When you are telling about an IP address, so you're writing an IP address or you're configuring IP address to your device. Okay, or you are telling some your IP address to your colleague or maybe to another system you are telling or you're configuring or you are telling to someone like this is your IP address. Only IP address or IP address and subnet mask is important, right? So when you are configuring an IP address, you should configure IP address and the subnet mask also. By default, the IP the subnet mask is always same, right? So for example, I'm going for 192.168.2.23. It's like a class C, and this default subnet mask is 255, 255, 255. If you are using default subnet mask, if you are telling or not telling, it does not matter. If you don't tell, it's a default subnet mask only. First, if it is a customized one, it means in case it is a different subnet mask from actual subnet mask, not from the default subnet mask. It is different subnet mask. So then definitely you have to mention it. Okay. So generally you have to mention IP address as well as subnet mask. If you don't mention the subnet mask, means it is default one. Second one is, in case the subnet mask is different from the default one based on that class. It's a class B IP address, but different subnet mask, not a default one. Then compulsory, you have to mention the subnet mask there. Okay. Whatever it is which class of IP address it is. If there's a different subnet mask, compulsory have to specify. How to specify? You can tell, for example, here I think I have written example 170.16.23.33. That is my IP address. And my subnet mask is 255.255.240.0. Actually, it is a class B. So default is 255.255.0.0. So I know the IP addresses. So I know it's a class B IP address. Then I know the class B default subnet mask is 255.255.0.0. But now it's a different one. It's not a completely class B. It has some additional number in it. So compulsory have to mention it. Either you can mention with a subnet mask like a 255.240.0, or you can mention like a /20 also. This /20 is called a slash notation type. Prefix, in some places they use prefix. What is meant by prefix? It is a representation of subnet mask. Representation of subnet mask. Slash notations, prefixes are CIDR method to tell what is your subnet mask. What is your subnet mask? If you take class A, default one 255.0.0.0, it's, if you write in the binary, it is 8 ones are there. So /8 represent a 255.0.0.0 is the subnet mask. Okay. /8. /16 means 255.255.0.0 because 16 ones are there. So what is the slash notation? It represents network bits, number of ones in the subnet mask. If you calculate, so number of ones in the subnet mask, that is our slash notation. /24. /20 means write it 20 ones, remainings are 0. So its total is 32. The first 20 is 1, remaining is zeros. Then you can convert back to the normal. So that is 255.255.240.0. Okay, /26. So 26 ones, remaining are zeros. Okay, if you rewrite, it is 255.255.255.292. Okay, so you can represent an IP address with a specific subnet mask wise or a slash notation wise also. Okay, for a default one, by default, if you don't mention also, it will take default. But if it is not a default, compulsory you have to mention the subnet mask. So you can mention like 172.16.1.23/16, or you can write 170.16.1.2/23, 255.255.0.0. If you mention /22, then it is different. Okay. Of course, I didn't write anything for how to calculation kind of stuff. But in some places, guys, subnet mask is important. In some places, slash notation you have to give. For example, in the Linux, you want to use TUI screen and you want to configure an IP address, and then you have to mention the subnet mask. You have to tell in the prefix slash notation, /24, /16, /8, like that you have to mention. Okay. So this is about a private IP and a NAT, and this is how to assign an IP address. NAT is there, that is there, okay. And then how to assign an IP address, manually assigning, automatically assigning. That is also we will discuss. Okay, if you got an IP address, so from where you will get it. So that is also discussed. Okay, so currently take a break, guys. I think you understand what is slash notation, subnet mask kind of stuff. When you are in the assigning IP address, there you will understand IP address, subnet mask part. And what is the default gateway, when we should mention the default gateway, when we should not mention the default gateway. That is also I will explain there. How much time you need it? 10 minutes is enough?
Yes, sir.
Take 15 minutes break. Okay? Be back
Okay.
at 10, 4:15.
Okay.